Okay, this is number 10 from test 2, part A. You're asked to find the antiderivative of 2 tangent of x. Okay, to do this problem, basically this is just a formula that you should memorize. We talked about how to derive this, taking the antiderivative using tangent as sine over cosine, and then doing u substitution. But ultimately, this becomes 2 times the integral of tangent of x, which we say same as 2 times the natural log of the secant of x plus some constant. Now, using properties of logs, this guy can come inside and become natural log of just secant squared of x, and then plus some constant, which is b. Okay, number 11. All right, number 11 asks for you to apply the mean value theorem on f of x equals x cubed on the interval from -1 to 2. And the mean value theorem basically says a rock equals I rock. So the a rock, I need to find my 2 endpoints. So plugging in -1, f at -1 would be -1, f at 2 would be 8. And so the a rock, my slope would be 8 minus -1. Oops. Over, all right, over 2 minus -1, which becomes 9 over 3, which is 3. And then the I rock that I'm going to set equal to that. Let me get rid of this line right here. It says I got to take the derivative, would simply be 3x squared. Setting 3 equal to 3x squared, I get 1 equals x squared, so x equals plus minus 1. Now, again, I got to make sure mean value theorem says it only ensures values on the open interval from -1 to 2. So on -1 to 2, the only value of these two, +1 and -1, that would work is x equals +1. I'm also a bad boy because I should have said that this original function is continuous on the closed interval and is differentiable on the open interval, so I can apply the mean value theorem. All right, the next problem is 13. All right, on 13 it says find the derivative dy dx of this implicit equation right here. All right, so to do this, I'm going to take the derivative of the first term, which is 1, plus the derivative of the second term is 1y prime, equals, now to do this guy, don't forget I got to use product rule, so the derivative of x is 1, so 1y, plus the derivative of y is y prime times x. Now I got to collect my y primes to one side and move everything else to the other side, so I'm going to get y prime minus y prime x equals y minus 1. Factoring out a y prime, I get y prime times 1 minus x equals y minus 1. So I get y prime, or dy dx, equals y minus 1 over 1 minus x. Now, that's not a choice, but if you just manipulate this equation, if I factor out a -1 from the top and get 1 minus y over 1 minus x, and then I multiply the bottom by that -1, I get 1 minus y over x minus 1, which is b. And those are those 3 problems. All right. Keep on sending me problems you want me to do.